If you like my content, please like, share and subscribe. Hello guys, my name is Rahul Datta and I'm back with another video. In my last video I have talked about basic pandas. So pandas is basically a data science library which is in Python, which is very useful in completing your data science projects, and every company is looking for now pandas and numpy skills should be in your resume as well. So it's very important skills that you have to have as a data scientist. And today I'll be talking about pandas only, which is a little bit of advanced pandas. But please do check out my few videos, NumPy part 1, NumPy part 2, and also my pandas part 1 video as well, and then come check this out. And if you have already checked those out, then please bear with me, do be with me, and I'll show you some amazing operations on pandas that we're going to use, that you are also going to use in your future projects. So let's start. So last in my last video I have talked about very basic operations that we can do using pandas, like creating a series, which is like 1D or 1D array, you can say, creating a 2D array or a 2D series, you can say. And also you can create a data frame out of it. How you can create data frame from dictionary, from list of lists. So these all I have talked about in my last videos, and in my today's video I'll be showing you some amazing advanced topics. So there are one of the main advanced topic in pandas is like multi-indexing. So let's see. So let's say I have a list called let's say array, okay, where I have a 2D list. Basically I'll say I have A, then B, then C, then D, then E, right? And also I have 1 2 3 4 5. Okay, right. Now I'll create a tuple, okay, out of it. So which will map A1, B2, C3, D4 and E5. So how you can do that? You can use zip function and you can create a tuple out of it, list of tuples basically. So what you can do, you can just say list, then zip of this arrays, but you have to provide this star. So what it will do, it will basically map A1, B2, C3, C3, D4 and E5. Okay, so suppose you want this as the index of a data frame, right, or a series. So you can do that. So now I'll create this multi-index before creating my data frame. So I'll say index and I'll import my two very important libraries, that is import numpy as np, import pandas as pd, right? Okay, so now what I'll do is I'll say pd dot multi index, okay, and I'll do from tuples basically, right? So I'll use from tuples and I'll pass this tuples. So I'll pass this tuples here, and I'll do, let's say, yeah, I'll delete this, I'll add one more, I'll display this tuples. So let's say I'll do A B C D E as first index, 1 2 3 4 5 as second index. So I'll just pass names equals to, so first index, okay, and second index, something like that. Okay, so now I have created my multi-index. So you see that it's a multi-index type of object and we have two indexes basically. Okay, so now I will create a data frame out of it, okay, using this basically, and where the index of the data frame will be this multi-index. Okay, So I'll create S or maybe def equals to pd dot data frame. I'll say my data will be like np.random.rand n, okay, and maybe I'll pass just 5 values, okay, and I'll say my index is basically this index, okay, and so just remember this index is basically the parameter of this data frame method, right? So you can also see from shift tab that we have this index. So this index is basically a parameter and this index is the variable which is having a multi-index type of object assigned, right? Okay, and I'll pass my column names as well. Let's say columns will be one column I have, so I'll pass column 1, okay. So my data frame has been created. So if you see my data frame, you will see that I have two indexes basically. So first index and second index. So this is a very unique way of creating a data frame with multi-index. Okay, great. But if you want to use the every pairing of this list, basically, like it's not like A1, B2, C3, D4 or E5. If you want every pairing like A1, A2, A3, A4, A5, B1, B2, B3, B4, B5 as your index, then it's easier to use another method called uh, from product. Basically, we have used from tuples, right? So we can use from product. So basically what you can do is, so this is, I'll say, using from tuples, creating multi-indexed data frame using from tuples, right? So I'll say something like that and I'll change this to markdown. Okay, now if you have to use, like if you are using all the pairings, all the possible pairings as your index, then use from product basically. So I'll just change it and I'll say from product, and what you can do is df underscore 1 would be like pd dot data frame dot from, sorry, pd dot multi index basically. Now let's say you want to use every pairing of this two lists basically as an index. So what we did here is like we have only take A1, B2, C3, D4 and E5, right? But if you want every pairings like A1, A2, A3, A4, A5 and B1, B2, B3, B4, B5 and 2, E1, E2, E3, E4, E5. So all these pairings if you want as an index, then instead of creating from tuples you can use from product. Okay, so here what we can do is we can just say that creating multi-indexed object, okay, from tuples, right? So yeah, I'll do this. I'll say now, yeah, I'll change this multi-indexed. Yes, yeah, it's good. Now if you want to use every pairings, then you should use from product. It will be very easy. So let's say I'll do this. I'll say from products. I'll change this to markdown. Okay, and I'll add one more. Right, so now what you can do is you can just say index equals to pd dot multi-index dot from product. Okay, so here you can directly pass this array. and you can just say this name as first index and second index. Okay, and yeah, here you say this. Okay, so it will create this index. So if you see now that all the pairings, basically the products, are in the multi-index object, right? Okay, so now you can use this index to create your data frame. Very easy. So now how many indexes we are seeing here? So we have this 5 elements here and 5 elements here, right? So we have total 25 indexes. So while creating this data frame, you have to pass 25 items, right? Like 25 in a column values, the samples should be 25, right? So that way, so what you can do is you can just say, instead of here we have passed 5, right? So you can pass 25. That's it. So while creating pd.dataframe, you can pass np.randn random.randn, then 25 is the size. Then you can pass index as this index. Okay, and you can also pass columns as, let's say, column 1. Okay, so now if you want to see this df1, you will see that yes, all the 25 samples are here along with this indexes basically. So this is another way of creating a multi-indexed data frame, right? Now I'll create a data frame and then we'll see that how to extract a multi-index from this data frame. One and two. Okay. So now let's see the data frame. So here I have to pass this, I have to close this. Okay, and after I see the data frame, it's like basically this. Okay, now if you want to extract a multi-index or you can create a multi-index, you can just say pd.multi-index.from frame. Okay, this is my method, and you can just pass your data frame, and if you run it, you will see that. So these are the basically data frames. Rahul 31, like these are the basically multi-index. Okay, Rahul 31, Bids 19, Sam 21, and Michael 22. Okay, so you can use this index, and you can create another data frame for this multi-index basically. So this way you can extract a multi-index from an existing data frame and use it in a different data frame or a series. How cool is it? As you can understand that this from frame method is a like complementary method to two frame, right? We have a two frame method. From series we can do a two frame to create a data frame, right? So, and this is a complementary of this two frame method. You can also pass lists directly or arrays directly into the index field of a data frame or a multi-index. You can also pass like these lists basically directly into the index field as well while creating the data frame, and that will also help you create a multi-index. Okay, so how you can do that? So you can, let's say we have a like array. Okay, let's say something like that, array which is a 2D array, and I'll pass let's say a, b, then let's say a, b, b. Okay, c, c, d, d. Okay, and I'll have, let's say 1 2 1 2 1 2 1 2. Okay, so something like that I have. If I have this type of array basically, and yeah, I'll just close it. Right, so I have this array. Oh, sorry, I'll just say this. Okay, so this is my array. So I can directly pass this array to an index while creating the data frame. Okay, that will also help me create. So that will also help you create a multi-index data frame. Okay, so I'll just say df underscore 2, let's say new data frame, where I'll say pd dot data frame. So it should be capital D data frame, and here you will pass np dot random dot random. Let's say it should be, so we have this 4 line here, 4 elements, and then 2 elements here. So for 4 into 2 it's 8. So I have to have a 8 elements basically as a sample, 8 samples, and in the index I can just pass arrays. Okay, it is should be array. Okay, so this df2 now will have a multi-indexed data frame. Okay, how? Because like here it will say a12, b12, c12, d12, and yeah, let's like that. So if you see df underscore 2, you will see that it's a multi-indexed array. So cool. And instead of 8 you can also pass like 2d. So for that you can also use df underscore 3 as 8 comma let's say 5. So this is also possible. So if you see df32, so it's like we have a 5 columns basically in this data frame, but the index remains same as we have used array as well only. Yeah, correct. An important thing to note is like, for creating a multi-index you have a names parameter as I show you, right? If you did not provide that names, it will be, the index name will be none. So let's say if you have this df3 index dot names, I believe, yes, names. So if you use this, so the index name, there is no index name, none, right? Because we have two index a b c d and 1 2 1 2 1 2 1 2, so both of them are none basically. So you have to provide the names in order to get these names here. This is an important info that you can keep in mind. And this index can back any axis of the pandas object basically, and you can and the number of levels of that index is up to you basically. So like you can use this index and create a data frame in this way as well. Let's say if you have a pd data frame, uh, and you can say that I have np.random.randn, and I'll pass size as 3 comma 8, and I'll say index is basically abc, let's say. So a b and c. Okay, and I'll pass columns as my index, so like index as my column. So if you do something like that, yes, so it is, so basically this array, I have to pass this array instead of this index. So now if you see that it's this abc and this columns now become like this multi-indexed. Okay, so this index can back any axis of the pandas object basically, and the number of levels is up to you, right? You can also do something like this. Let's say you have this data frame. Okay, I'll just take 6, and instead of this index I'll pass array, and I'll say 6, and similarly for column as well I'll pass 6. Okay, so the error is basically, it says 6 6, I have 8. Okay, So I'll just say 6 and then, so this is basically, it says 8 by 8. So I have to pass, instead of this array, I have to pass this index basically. This is the index that I have to pass. So I can say not here, should be here. Yeah, instead of array I'll pass index, and here also index. So if you see now, so it has now like this. So you have this first index and second index, which is the name of the indexes basically. So now if you take it in a df underscore 4 maybe, and if you try to run this, you will see something like that, and also you'll see the index name as well. Okay, and yeah, this is the columns are also similar to what we have in index. Okay, yeah, so this is a kind of stuff that you can do using multi-indexing. So the main purpose of using this multi-index is basically to grouping or for selection or reshaping, and we'll also describe this in my later in this video as well, why we need multi-indexing. But this is also a very important thing to note, that while using grouping group by, you have to have this multi-indexing concept. Okay, now how you can access these indexes. So basically what we used to do is like we did data frame dot index, right? But like if you want to have this only first index or only the second index, so how can you access that? So for that you have to use this method. So we have this df, and let's say we have this index, and you can do get level values, some like this. Okay, so you can say 0, so it will consider this first index call index basically, and it will have, if you are doing 1 it will do second index, and also you can pass name as well instead of index. So if you do 0, you will see that it's a and then b, right? So it is like this. And if you do second index instead of 1, if you do this second index in a string, you will see that it's 1 2 3 4 5 1, right? So these way you can use leverage get level values method to get the first index or second index in a list or a numpy array. Now how you can access the columns of a multi-indexed data frame, right? So for that what you can do, so let's say so we have this df4, right? This is df4. So now you want to only access all the A columns basically. Okay, so you can, similar to what we did, is like you can just say A, and it will only fetch this A. So this is basically a column. Okay, so A1 A2 A3 A4 and A5, it will be fetched. So if you run it, you will see that it's 1 2 3 4 5 basically these values. So you don't have this A basically because we have already used it here. And similarly if you want to see B, you will see that it's the last column basically, you can also get. But if you want to have 1, okay, only the first column of A, the first column, so how you can access? So this indexing is basically something like this, A comma 1. If you pass this, you will get a, what is this? This is basically a series. Okay, you will get this series. So this is the first column. Okay, 0.8, 0.1, 1.53. So this is the value. Okay, so this way you can access a multi-indexed data frame columns or the rows of a multi-indexed data frames. Okay, cool. Now a very interesting thing about this multi-indexing is, like, this multi-indexing keeps all the used unused levels intact. For example, if I do df by dff4, and then I only take, if I only take a, let's say a, and then if I do columns, let's say first I'll show you what is df. This is a, right? So there is no b column. But if you still do this columns dot df4 dot columns, okay, and then say if you do let's say levels, okay, so if you do that levels, you will see that all of the lists are intact, a b c d e 1 2 3 4 5, because like here we have passed index all of them. Let's say where, when I created this, here I have passed index, right? So this index has all of a b c d e 1 2 3 4 5, right? This index. So you can see here in this index I have all a b c d e and 1 2 3 4 5, right? So but since I have used that index here only while creating this, all of these levels are intact. But we're not using it here, right? So to see what are the used indexes, so I can just say get used levels or get level values, okay? So that way if you do this, like columns dot get level values, and yes, this one, and say 0, now we'll see that sorry, yeah, you have to remove this and see. Now you will see that only the used indexes, okay, and the used indexes are, like used columns are intact. Now you can see a and b, right? So here if you see, this is my df4, right? A and b, a 1 2 3 4 5 and b1. So that is what you can see here. So levels in keeps everything intact. So this is basically helps you recomputation was very performance efficient, hence it keeps all the levels. But if you do get level values, what it will do, it will only get you the used levels. And if you do not want these levels, like whatever, if you have used it, you want to keep that and remove everything else, then you can just do remove unused levels. So there is a method called remove unused levels. Yeah, so here if you do this, and so if I write remove unused levels, so now it has been removed. All the existing, like this CDE has all been removed. So now if you do levels, you will see that levels, let's say, so basically you have to use it in a, let's say, new multi-index, and if you run it, and now if you want to see the levels, basically get level values and see the values. Okay, so I have to remove this, and now, so now if you see that all the unused levels are removed. So this is basically it. So it will keep all the unused levels as well for recomputations. It's performance efficient. But if you don't want to use it, you can just say remove unused levels, and you can keep that in a new multi-index. And those, now if you do values, or you can just say even no, not only this level values, you can do this as well, levels. It will also keep only the one that is required, only the one that is used, not the ones that are unused. Okay, so it has been removed. So this is a very important features as well. So this multi-indexing concept is very important in your future data science projects, or any kind of projects for that matter. So very useful thing, please keep this in mind. Okay, now there is a concept of like data alignment. Okay, so you can have like any number of operations you can perform over this data frame, and it will act as smooth as you expect basically. So data alignment is what is basically is something like this. I'll just say this. Now if you want to see the first two rows basically of this data frame, so what the data frame is like this. Okay, so now if you want to have this row and this row, how you can extract that? Using the index slicing, right? Something like this you can do. Let's say you can do this, right? So you will get only the first two rows. Now if you want to add these two basically, so let's say something like this. Okay, what will happen is basically it will add, so for corresponding elements will be added, so like this minus 0.80 and this minus 0.80 will be added, and similar to this minus 0.10 as well. So these will be added, so basically these will be doubled. But since we do not have these rows in my next, or in my second df, that is in this df, all rows will be termed as nan, because it will not have any thing to perform on some operations on anything, right? So in that way it will show you nan. So if you see this, so all these first two rows are doubled, but since we do not have anything on the in this second data frame for third, fourth, fifth and sixth rows, it will show it as a NN. Okay, so now if you want to get similar to what we did here, like if you want to get a corresponding alternate rows like 1, 3 and 5, you can also say something like this 2, and it will return 1, 3 and 5. Now if you want to add, then our corresponding alternate elements will be basically set as nan, right? So if you see here 2, 4, 1, these three are not like this data frame have these three rows are missing in this data frames, right? So that is why while adding it will skip and it will display as NA. So this is also a concept where this is called data alignment, and this is also very important, so keep this in mind as well. So I'll share this in my YouTube descriptions, please check it out. Now two very important methods are swap levels and reorder levels. We have this df data frame, right? Now if you want to swap first index and swap second index, so how you can do that? So you can use df4 dot swap level. Okay, so you can use that. So it's basically swap level and I think reorder level. So here you have to pass what here, if you see this, it will say that pass swap I and j in a class. So basically you have to pass the index like 0, 1, 1. So you have to pass 0, 1, it will swap basically. So if you just pass the indexes, which two indexes you want to swap, so you can say 0 1, and on which axis, it's in the row 0 axis, right? So if you do that, you will see that it has been swapped. So the second index is now the first in the here, and the second index is here. Okay, so you can achieve this functionality using reorder levels as well. So if you do reorder levels, yes, so here you have to say reorder levels. So here you can pass this order. Okay, so you have to pass the order here. So here you have to pass the order. Swap level itself, meaning that it is swapping, you have to just pass whichever index of indices you want to pass, and that will swap automatically. But in reorder levels, you have to pass the order basically, and that way it will get rearranged. Okay, cool. So here you will pass the order. So I'll pass order basically. So this does mean that it is not changed. df4 has not been changed, right? So the value that has been returned, it returns a data frame, so that has been changed. So df4 is still intact. So if you just see the df4 once, so you will see that it has been intact. Okay, so now if you want to reorder using these reorder levels, so you can say reorder levels, you can pass the order in a list, so it's 1 0, and it should be on axis 0. So if you do that, it is also swapping the levels, the indexes, right? So these two are very important methods: swap levels and reorder levels. Okay. And one last topic about multi-index is you can sort this indices to sort the series or our data frame value by its index. Okay, so let's say I'll create a new series using my old array, so which is this. I will use this, and let's say this I'll also import random to shuffle this. So let's say random dot shuffle I do array, and if I see array now, okay, so okay, I'll just pass the I'll create a tuples out of it. So let's say I'll do this star, so star array. So now we have this. I will put it in a, okay, so I have this value tuples now. If you see this tuples, okay, and I'll do a random shuffling of this tuple, and let's say, okay, now if you see tuples, okay, yeah, it has been shuffled. Now if you want to create a, let's say, a new index of new multi-index series, so I'll do from tuples, and I'll say this should be our this tuples. Okay, what else? I do not need to pass, yeah, sorry. So here I'll pass my value, let's say random dot rand n. Okay, and I'll say 8, and in index I'll pass index or tuples basically. Yep. Okay, multi-index are from tuples. Okay, correct. So here I'll just do tuples. Okay, so this is my index basically, right? and I'll create a series now, pd.series, which will have this as a value rand n, and which is 8. Okay, now I'll pass this index as index, right? So I'll run it from here once. So I shuffled it, it has been shuffled. I created a series, and it should be index equals to, what is the value? Okay, so it should be 5 because I have 1 2 3 4 5, right? 5, yeah. So I created my series, something like that, and it has been reordered, right? Now if you do sort index, you will see that it has been rearranged. So something like that you can do. So it's very important as well. So sort index. So this is all about multi-index. So you can use it very effectively. You can now you can I hope you can use it very effectively in your project or in your program. Okay, so now we're going to talk about group by. Okay, so we have set the base for the group by, which is multi-index is the base for group by, or I mean you can use one index as well. But so to get the feel of group by, you have to understand the fact what multi-index is. So now we'll going to move to group by. So group by is also a very important feature of Pandas. Okay, it's a very powerful feature, and you should use it whenever you require to group the data, or to like mark the database based on some conditions, some functions, anything. Okay, so for that we need to use group by. So let's start. So what is group by? Okay, cool. I'll just move it to markdown, change this, right? So let's I'll take one data frame. Okay, I'll just take it from the web, any data frame, like a comprehensive one. So let's take that. So I have this data frame with me. Okay, so it's a very straightforward data frame. So you can see that I have, so there are like class, order, and max speed. There are 3 columns, 4 5 indexes and indices, and we have, these are the values, right? So it's a very straightforward data frame that I took from the web. Okay, so I ran it. I'll just say df, so you can see that it's a data frame where I have these 3 columns and 5 indices. Okay, cool. I have like one inane value as well. Now I want to group this data frame by class. Okay, so I have like 2 birds and 3 mammals, right? So after I group by class, what I'll get one entry of bird and one entry of mammal. So the group by is basically consists of 3 steps. So the first one is to split the data, to apply functions on the data. Okay, and the third one is to combine the data. Okay, so that is the 3 parts, 3 sections that a group by is, and underlying Python is doing this kind of these 3 steps for a group by function. Whenever it encounters a group by method, it actually performs this step: splitting, applying a function on it, and then combining it, right? So how I can do that? So let's say I'll say grouped class. Okay, so this is my new data frame, and what I can do is I can just say that this is my data frame dot group by the method, and I can say that group by class. Okay, so I'll use class. So you have to pass this in a list. So inside this group by, if you do shift tab, you will again see that the by. So by which column you want to group or by which index you want to group. So that is the by. And by default axis is 0, that is on the row level it will group the data. And then we have several other parameters as well, like sort, then squeeze, drop na. Yeah, so drop na is basically true always, because whenever like by default drop na will be true, because whenever you group it will exclude this drop na and it will do the functions that you are applying on this grouped class, okay, that it will perform excluding the nn. But if you want to keep that nn, you can just say drop na is true, is false basically. So you should not drop any na, okay, but by default it's true. Okay, so we'll go there. So let's just see what is this grouped class. So grouped class is basically a data frame grouped by object. It doesn't contain, so it's just an object. So if I just run it and see the type of this thing, you will see that it's a pandas group by data frame group by object basically. Okay, it's nothing else. So this part is basically a splitting. Okay, you can say that it's a splitting of, internally it splits the data by this class, and it identifies that which are the class that I have to like actually do the functions on, like whatever functions we are going to apply on this grouped class, that it will do. But internally it has like it has make it clear that okay, so I have this class, and this class has these two values and these three values, unique values I'm saying. So it has two unique values basically. So that splitting has been done internally inside Python. Okay, so now this is done. Now what I can do is I can say that so I can do I can apply functions on this group class basically. So what functions I can apply? So I can apply many functions. You can just do this and then do tab. You will see that you can apply many functions. Okay, but like most common functions are like basically so I can say that most common group by functions are like sum, okay, let's say mean, then you can say that first, okay, then you can say the last. Okay, so there are like lots of stuff that you can do with this group class basically. So we'll show some basic functions, and that is mostly required in your data science project. So whatever is required I'll show you, and rest you have to explore. And if you do not understand, or if you are unable to understand any stuff, anything, just let me know in the comment section below and I'll try to reply. Thank you. So let's say I'll do this sum. Okay, sum. So what it will do? So it will do basically, so sum is basically only work on numerical stuffs. Okay, so if you run this, so you will see that, so we have only, so it will keep only the unique values of class, because we have grouped by class, and the numerical values are added, and it skips the categorical value basically. So if you see this bird, so bird has like these two lines. So 389 plus 24 is 413, and 80 plus 58 is 132.8.2. Yeah, right. And it excludes this NaN. So this is basically sum. You can do similarly. You can do what is mean. Okay. So it will mean. So it will do the average of 389 and 24, which is 206.5, and also 80 and 58, which is 69. So if you do this mean, it will do the average. Okay, you can use first method as well. So it will only take the first value of this group. So it will take 389 and then 80.2 basically. So you can do this as well. So grouped class dot first, right, and similarly if you do last, it will take the last value. Okay, so which is 24 and 58. So these are the basic operations you can do. You can also, if you want to apply multiple functions, you can also do that using this grouped by dot aggregate. And then here you can pass multiple functions. So functions, there are like multiple functions you can pass. You can just say that I want to have, let's say, mean, let's say sum. Yeah, so yeah, you have to pass it in a list. Yeah, so you can do this kind of stuff, and it will basically do both of them on this class. So if you run it, you might get a warning because of this, I think this order, but yeah, you can exclude it as well. So yeah, if you run it, so you see that on this max speed, it performs both the functions like mean and sum. So mean and sum, so both have been performed. And here what's the warning? It says, yeah, so it says that order did not aggregate successfully. So yeah, because like this, since this is a, yeah, this is basically a categorical value, so it has not been grouped. Yeah, as you can see that you cannot mean or you cannot sum both of them, right? Yeah, but you can do the concatenation as well, that I'll show you later. But yeah, but currently you cannot do mean or sum, as you can understand easily. So yeah, we can remove that, but this is what we want to check. Yeah, so this is for aggregation. So like you can apply functions, multiple functions, apply same functions twice, thrice. Yeah, so yeah, this is it. So you can also loop through the groups that you have that you had already with your this group class. So if you just say grouped class, and then you do this method groups, so you will see that what are the groups basically we have, and uh, what columns that the what rows that group contains. Okay, so if you run it, you will see that. Okay, so this is a attributes basically. So yeah, if you see that this is bird, and bird has combined this two, basically these two rows. Okay, and then mammal combines these three rows. So basically this, so the index has been in here. Okay, so it's pretty straightforward to understand that what are the groups and what are the actual underlying values of that groups that has been used to mean or sum. Okay, the values. So this is also an important stuff. So you can also say like just you can do for item in grouped class dot groups, so you can print it basically. Yeah, so you can just say print item as well. So it will print bird and mammal, and so this is basically it. And you can say item comma value if you want to do. So you can say dot keys. Okay, so you can, I think, remove this, and if you run it, yeah, you will. Now if you print the value, so you'll see that it has been, so the values are also here. So this is basically, you can use this groups attribute to find out so for like a, so like this is very small data frame, right? But if you have like multiple millions of data in that data frame, so you can easily understand that what all columns have been grouped. So to understand it quickly, you can use this groups attribute. You can obviously understand that if you do this, you can also apply this len function, because this is basically a dictionary. So it will return these two. So what are the groups? So two groups basically. So it will return two as well. So this is also important thing to know, just to know that. Yeah, it is useful. And as I told you, like you can have so there are like lots of attributes that you can also use. So you have, since you have this sort. Okay, so if you want to sort it, so it by default it's sorted, but if you want to like if you don't want to sort, then you can set it as false. So also you can do this as index as false as well, which will so then pandas will automatically assign some 0 1 2 3 4 index instead of the index that you can see here. So if you see, this is the class index, because since we grouped by class, the grouped by data frame has the index as the class, but you can just say as index equals to false to make it the usual indexes, which is 0 1 2 3 4. Okay, so yeah, this level is important. So this level is basically when you have multi-index. Okay, so if you have multi-index like first index and second index, then using this level you can sort, you can group the values of this data frame. So I'll show you that. So let's say you have another index. Okay, I will just take this, or let's say I'll have this data frame basically. So I have copied it from the my other notebook. So it's like this, and I have created this multi-index, and I'll use as my index in while creating this series. So I'll create the series. So I showed you how to do the group by on data frame. I'll show you now in series. So in any data pandas object you can use this group by basically. So I will say pd.series is np.random.random, and which is like I have 1 2 3 4 5 6 7 8, right? So I have this 8, so I'll provide 8 here, and index should be equals to index basically. Okay, so I have this series with me. So now you can group by the first index or the second index, okay, using this level. So you can say grouped equals to s dot group by, okay, and then you can say level equals to 0. If you do that, it will group by this level, first level. Okay, so let's say grouped, and I will do a sum maybe. Okay, or I'll take the first, maybe it will be easy to understand. So if you see that bar, buzz, foo, quacks, so yeah, it has been grouped by this, and it is taking the first value. You can do sum as well, so it will be easy to understand. So you see bar, and it has been, so this 80.88 and 0.47 has been added, correct, and similarly for bars foo as well. Okay, now you can do a similar thing for here as well, like it says let's say if you do 1, it will grouped by 1. So let's say group dot sum, you will see that it has been grouped by 1. So 1 2 1 2 1 2 was 1. Yeah, so we have two only values, unique values, and rest has been added. Cool, right? Yeah, and you can also, so instead of this you can also pass, I think, the name, so which is first and second. So level, if you pass second, that should also work. And this both should have derive the same values. That says sum. Yeah, cool. So this is also can be done for multi-index. You can use this level to group by index. Okay, now you can group by index and column both. Okay, so now uh, you can group data frame by its index and its column. Okay, you can use that as well. So for that, what I'll do is I'll just create a data frame out of it. So I've shown you the series, how we can apply group by on series. Now I'll show you in a data frame as well. So let's say this data frame, and I will say that this is a I have to pass a dictionary here. Okay, so something like this dictionary, and so let's say this is my B column. Okay, and my A column would be something like this. Okay, and here I'll pass let's say X, Y, say. Okay, then Y, then Y, then Z, then X. So I have these 2, 3, 3, 6, 7, and one more, it says Z. Okay, if I do this, quickly I'll do this, and yeah, so I have my data frame created. I run it. I will just change it to df maybe, and I'll say what is this df. So now if you see, the df is basically we have multi-index and we have two columns A and B. Okay, right. Now we have to use a specific function called this pd.grouper. So if you see, this is a grouper allows the user to specify a group by instructions for an object basically. So I have to use this if I have to like group by both index and columns. Okay, so I'll say grouped by first index, which is 0th index, and then a column. Okay, so this is my data frame name, and this is my basically data frame group by object, and I'll say df dot group by, and I'll say you have to pass it in a list. So let's say pd.grouper. So this is my group by object for the index. So I'll say pd.grouper, and level should be 0. Okay, so level I'll pass 0, and I'll say my column would be XA basically. Okay, so this is my data frame group by object, and let's say I'll do a sum over it, and now you can see that the one where I did the group by index group by on, that is the level 0 and column A, so both have become the index, and on B the sum has been applied. Cool. So this is how you can do that. Okay, so this is pretty much it. Next I'll move to a very interesting topic, which is merge, concat, and then you have compare, and then you have join and compare. So these are also very important stuff to understand. So I'll do this, and I'll change it to markdown. Okay, let's see. Okay, so what is merge, concat, join, and compare? So I'll start with merge. Let's say I'll create a data frame called left. Okay, so I'll do pd dot data frame, and I'll pass this, let's say a column called, say, key. Okay, I'll pass something like 1 2 3 4. Then I have a column called A. I'll pass let's say 10 20 30 40, and then I have P. Okay, I'll pass 100, 200, 300, 400. Okay, and I'll have also index, which is, let's say, 0, 1, 2, 3. Okay, so this is my first data frame. Yes. Okay, cool. I'll create another data frame called write, and I'll use this. Okay, I'll keep this key same, and I'll do this 50, 60, 70, 80, and something like this, 2000, 3000, and 4000. Okay, now if you do this pd.marge, yeah, and if you do shift tab, you will see that you have basically, so two data frame, left and right. So you have to pass, so the first two arguments are like two data frames. The third argument is how you want to merge basically these two data frames. So by default it's inner. So inner meaning like it's the key that is present both in both left and right. On those keys it will get merged basically. Okay, and there are like always left on, right on, so like what to keep, what not to keep, and there are like if you want to sort it or not, so there are like lots of other parameters as well. We'll gradually see that as well. So we'll do left and right. Okay, and yeah, and you have to also pass on what basis you want to basically merge this. So you have to pass this on parameter as well, which is, and you have passed the column name. Okay, so if you do this and run, okay, so I'll change this to 4 5 6 7. Let's say 4 5 6 and 7. Okay, so let's say now you merge basically left and right on key. Okay, so the key will be common for both of them, and it has been like this. So a underscore x, b underscore x, a underscore y, b underscore y. Okay, so it has been auto renamed. So it has been auto renamed because this we have the same column. So let's say I'll just change it to maybe, let's say, a1 or b2, and now if you run it, it will see that so on this key the whole left and right data frame have been merged. Okay, now let's say you have um, two keys. Okay, so I'll just copy this, and I'll have, let's say, key 1, and I'll pass key 2, and yeah, something like this, and I'll do a b c c, let's say. Okay, right, and I'll add here as well key 1, key 2. Okay, I'll say 1 b a c and c. Okay, so I think it is comma is required, and what else? Here is also comma required. Right. So you have this left and right. Okay. Now if you want to join based on key 1 and key 2, so whatever the common between this key 1 key 2 will have been kept once you do this merge. Okay, so let's say if you do pd dot merge, yeah, and you do pd dot merge, and you say that left comma right, and then you can say on basically key 1 and key 2. Yeah, so if you do this, you will see that so only 0C and 1C are present in both of them. If you see, I mean 3C and 4C basically. So if you see 1A, the 1A has not been present here. Okay, so 2B also is not present here, but 3C presents, 4C present. So you have 3C and 4C in the output merge data frame. Okay, so and it has been merged with this. So this is basically you can use how you can use this multiple key to merge both data frame. Now there are like lots of thing that you can use with this parameter called how. Okay, so by default I told you that it's inner, but you can make it as fuller, okay, full outer, or left, right, anything, so that you can do on how. So let's say you do left and then say right, then say how. You have this how equals to, let's say you do left and you keep this on as is, so key 1 and key 2. Okay, so you see that so all the left combination has been kept, 1A 2B 3C 4C, 1A 2B 3C 4C, and whenever you did not find any value for any particular cell, it has been put it as nan, not a number. Okay, so this is how left works. So yeah, the left will be given the priority. Okay, and similarly for right, it will be all this 1B 2A 3C and 4C will be kept. So if you do this with right, sorry, I'll just say this with right. On this, I think so. So basically, I have to run this again. I'll do this, and then I'll run it. Run this. Okay. Yeah, I'll do. Yeah. So if you see now, 1B, 2A, 3C, 4C, all the combination of key 1, key 2 for right has been kept, and accordingly, left for the left data frame, those values that are not present have been identified as not a number. So this is left is basically left outer join, you can say. Right is basically right outer join. You can have full outer join as well, so it will be a union of all of them. Okay, so that is also you can do. So there are like lots of other parameter on you can use as well. So there is one cross join as well, cross. So the cross is basically a cross join on the SQL terms. Okay, so it is nothing but the Cartesian product of left and right data frames. Okay, so this is basically pd.merge, and now I'll go to concat. So this is also very important. I'll say pd.concat. I'll change this to markdown. Okay, so very important, please concentrate. Let's say I have I'll create two data frame. Okay, let's say df1, Now you can do concat. Okay, so let's say what I'll do is I'll just say concat df underscore concatenated. I'll just say df new, or I'll do pd dot concat basically, and you just pass df1 df2 in a list. Very important. Okay, so now if you run it, you will see the df new to be all the values. Okay, because it's a full outer kind of join. So if you do shift tab, let's say shift tab, here you will see that this join is outer, so this is full outer basically. So you will get everything, union of all the data frames when you do concat. But on merge it will be based on the key, and the how is basically the how of the default how is inner. Okay, but here it's outer, so it will have everything. Okay, right. So this is basically on axis 0, on the row level it has been stacked, so vertically it has been stacked. Okay, now you want to like name uh, the after this concatenation, you really don't understand, right, where it has been like from how much to how much is like df1, and then from which line to which line is df2. Just in case if you want to clarify, or if you want to identify, you can just say a key, there is a key concept. So let's say you can do something like this. I'll move it, and you can pass these keys. Okay, so and here, since we have two data frame, you can say it's 1 and 2. You can just pass something like this, 2, and it will assign keys before this. Okay, before this index basically. So if you see that, so now this 1 corresponds to entire df1, and this do 2 corresponds to entire df2. So you can make use of these keys to identify df1 and df2 easily from the derived data frame. Okay, cool. Now we will do the concat on the column level, that is it will be stacked horizontally. So for that, what we have to do, we can just say axis equals to 1. You already know that. So axis equals to 1. But here is some catch. I'll show you that. So here you'll see that this ABCD is NaN, right? And this is also NaN. Why? Because this combination does not already in the df1 and df2, and that is why you have got this. So for 4a is not present in, so like, so if you see this df1 and df2, let's I'll print it here, df1, and this is my df2. Okay, so this is 3a. Okay, so 3a doesn't it, here we don't have 3a, right? So hence it will be an NaN. So for 3a it is an N, 2a it's an N, 0. So whatever combination is not exists in that particular df1, that row will be NaN, not a number, but rest will be whatever what combinations is already there, that will be present. Okay, but since we do not use this stuff, that is join is automatically outer, so it is full outer, so it is union of both of them. Okay, right. Now you can change basically the how parameter, and let's see how it works. So I'll do the stuff is basically I'll do this how, what is the parameter, it is how or join. Okay, so join, so you have to pass this join, how you want to join basically. So if you want to join inner, so this inner is basically will try to find the concat, the intersection of df1 and df2, and in this case we don't have any intersection, so I think it should be blank, the resultant data frame should be blank, and yes it is. So the resultant data frame is blank because it did not find any uh, any intersection of df1 and df2. Okay, now let's say I'll create another df3. Okay, and I'll say I'll just do this as 0, 3, 5 and 7. Okay, something like that. I have df3, let's say, or df2. Okay, so now if you want to join df1 and df3, let's say what happens. So I'll do a frames list, which is this, and I'll do pd.concat. I'll say frames. I will say access is equals to 1. I will say join is inner. Okay, so now see that df1 has 0, 1, 2, 3 index, and df3 has 0, 3, 5, 7. So 0, 3 is common, right, between df1 and df3. So let's see what happens. Yeah, so 0, 3, so both of them which are common between this df1 and df3, the intersection of df1 and df3 has been present. Now that's pretty cool, right? So now how you can use this concat? So using this inner or using this axis 1, you can just the Python is basically stacking this horizontally, and which frames? The frames are basically df1 and df3. Cool. Now since we have only 0, 3 here, because df1 and df3 intersection is 0, 3, but if you want to keep all the index of df1, so where is the df1? So df1 has 0, 1, 2, 3, all the index, right? So if you want to keep all the index, then you can just say you can do this, and you can say dot reindex basically, and you can say df1 dot index. So in this way you can keep 1 and 3 as well. So sorry, 1 and 2 as well, because 0, 3 is already there because of this join. But since you did the reindexing of the derived data frame with df1 index, then it will include 0, 1, 2 as well. But since we do not have any intersection values, it will obviously be an n and n and n, but the shape will remain same basically. So that is how you can use this reindex to basically uh, reindex back the resultant data frame to the desired data frames index. Okay, so this is also a pretty cool feature. Yeah, now let's say you want to concatenate two different dimensions objects. So let's say our data frame with a series. Concatenate. So let's say I'll have a dictionary, I'll have a data frame and also a series. So a new series may be something like this. I can say that say x, y, z 2. Okay, something like that I can create. So yeah, something like this, and I'll just pass name as well equals to x. Okay, so this is my series, and I have df3 as well, so it is this. Okay, or maybe df2, let's say df2 is 1. Yeah, so now you can also do this concatenation of df1 and s. So it should be again in a list, and you can use axis equals to 1. So it will just add this series after this d, okay, as an x column. So yeah, something like this. So it will add, just because since we have both s and data frame has the same indexing, so it will just add it in at the end of the series, because that is how it has been ordered. Cool. So this is also a very important useful feature of uh, concatenation. So now it's time to go to the next topic, which is pd.join. So I will say pd.join and I'll do this, change it to markdown. Let's start. Okay, I created two data frame, right, left and right, and now we want to join basically. So, and I'll do one more stuff. Let's say instead of this I'll pass k5 maybe here. Okay, right. So now if you can just say left dot join. Okay, uh yeah, join, and then you can pass right. So columns overlap but no suffix specified. Okay, yeah, so I have to pass this how basically should be outer. Yeah, if I do that, okay, so I'll say k0, let's say k2 here, and then k3 here, and then k5. Okay, so I will run this, and this. Okay, so this error is okay, I think I have to change the column name, so I'll do, let's say A1 P1 C1. Yeah, so that is pretty cool. So I can just change my column name. So now I run it. Yeah, so this join is basically, so now if you see that it has since we have used outer, so the outer is like a union of all, as you know. So it will have all the columns A, B, C, and A1, B1, C1, and it has all the index as well, K0 to K5. Okay, so now since K5 is not present in left, so the corresponding value of K5 should be nan, and K1 is not present here, so the corresponding value of df2, the left right data frame, will be nan as well. Okay, so this is basically how you can join, and remember that join is much faster as compared to other merge or concat. Okay, so try to use join as much as possible, but it's little tricky. You can use concat and merge as well. It like, but in case of like you have 10 million data in a data frame, okay, in that case, yeah, to improve your model performance, you can use join instead of merge if you are facing any performance efficiency issue. Okay, so that is a tip that you can use as an advice. And here you can see that you have this on this how left is basically the default one. You can use anything, left, right, cross, outer, anything. Okay, so on index level, so the basically it's on index level, you can also pass none as well. Okay, so either of them. So this is right, and it can be series as well, as you know. Okay, so this is how you can use join. And then we have compare. So compare is also very important, because like if you want to compare two different data frames, okay, and find out whether both of them are same or not, so you can use compare. Okay, let's say I'll create another data frame. Let's say compare df1. Okay, so this is my data frame. I'll say So guys, I have like writing every other data frame. I am not copying anything from web or something. So this is not a copy paste that I'll teach you. So basically whatever I'm writing on my own. So this is also an effort that you might appreciate. Yeah. Uh, so like, yeah, I'll just say this. Okay. So now, yeah, I have, let's say, three columns basically. Column one, and then I'll pass some value to it. Let's see what I will do. Column 2, and I will do column 3 as well. Okay, column 3, let's say something like that. Okay, so I'll pass 1 2 3 4 5 here. I'll pass a let's say, yeah, A B C, let's say C, and then D, and then E, let's say, yeah. And you have another which is 1.0, 2.0, 3.0, let's say 1 np dot nn also, and then 5.0. Okay, and I'll just pass one index as well here. So index is let's say abcd, or maybe 0123. Okay, cool. So what is the issue? Column 3, 3, 3, ABCD, 1, 2, 3. Okay, yeah, you have to pass 4 as well. Right. Now let's say I'll create a copy of this compare data frame 1, and I'll name it as 2. So which is this dot copy. Okay, and let's say I'll now change some value of it. So let's say I'll change this 1 4 to maybe, so I'll just run this compare data frame 1. So the first column, first row, so that is this, and 0 1 2 3, so I'll pass 2 here. So this value B, I'll change it to, let's say, R. Okay, and one more thing I have to change. I'll change this 1, or let's say 3, third row, that is fourth row basically, and fourth row, and the first, let's say 0. Okay, I'll change it to 10. Okay, so now if you try to see the df2, so you see that I have changed this to R. Okay, I'll just use lock, that would be easier, and I'll say, instead of this, I'll say call 1. Okay, and instead of 0, sorry, yeah, instead of 2, 0 1 2, so call 3 I'll use. Okay, column 3 I'll use, and for 0 I'll use column 1. Okay, so this is my value, and this is let's say 10. Okay, so I have to pass log as well here. I will do it from here. Okay, cool. So this has been changed to 10, and this has been R. So now if you do the compare, so pd dot compare so C. Okay, so I think we have to do this compare to df1 dot compare. I think you have something like this, compare, yes, and then you pass 2. Okay, so first what it will do, so compare, if you see again, so the compare is basically how it has been shaped. It says that it is other, align axis is 1, okay, and keep shape is false, keep equal is false, okay. So it will only keep the one that are changed basically, okay, and the rest it will skip. So see that this 2 and r has been changed, so r has been changed, so hence it has to keep this row, okay. And so this is self, this is other, okay. So this is basically the compare 1 is self, and the compare 2 is others basically. So it was self, for self it is 2, so compare 1 has 2, yeah, 2.0 basically. And in here compare div2 it's r, and for call 3, and for call column 1 it was 4 for compare the data frame 1, and for other it is 10, that is div2 is 10. So it will only keep these rows, okay. But if you want to keep the shape if you want to keep the shape, uh, then you can do this. You can say keep shape is equals to true, nothing else. Keep shape equals to true, okay. So it will keep the entire shape, and it will only show you the values that are changed, okay. So yeah, because I have changed, previously I changed it, so it was showing 2r and 410, okay. So yeah, so this is basically it. And also you can use this align axis, okay. So for that, if you do align axis, then true, then it will, yeah, so sorry, so it should be 0 or 1. So if you do 0, so yeah, right, so if you pass this 0, then it's basically will keep the axis aligned, okay. So this is pretty much it for pandas, advanced pandas. And in the next video I'll be showing you a end-to-end project on pandas and numpy, and how you can make use of one data set, and then use these pandas skills to extract some insights from the data set using these pandas. And that is exactly what data science is doing in nowadays, okay. So that will be also a pretty interesting stuff. But before that, please, if you did not check out my other videos of numpy part 1, part 2, and pandas part 1, so please check that out, and then you will be absolutely ready with the first data science project that we are going to do in the next video. So till then, goodbye, happy learning, and I'll see you in my next videos. And also please like, share and subscribe if you really like my content. That will really motivate me.